So welcome back to Statistic 1, Chapter 1 Exploring Data, Topic Measure of Spread, Range, Standard Deviation, and Variance. So for the first term, range, is a very easy term. Range is the difference between the largest and the smallest data of a data set. Like for example, you have a data set like this, 182, 86, 20, 400, 9,001. So the 9,000. So the smaller, the difference between the largest and the smallest would be 9,000 minus 1, 8,000, and 99. So the range is very easy. It's the difference between the largest minus the smallest. So for standard deviation, so deviation means that for many layers, like we have a lot of layers. So when we draw something scale line means that you can put whatever values in it. So here is the mean. For example, I take here the mean of a data set, the mean of a data set. Mean here. So other range something like this in here and here and here. The length of this one is not important. The important thing here is the location of these things. So here is the mean. I will take a different color to make it clearer. Here, the red one will be the mean. Red line here. Red line. So the distance between a data to the mean of the group is called the deviation. The value. So the standard deviation would be the standard deviation of the whole data set. So it is calculated by this way. So for x value here, we call it x. X value is called x. So the mean would be x bar. So take x value minus 2x to the mean. Okay. First step. The second step, we take square of that. Minus bar square. Okay. Then we take sum of them. Sum of x there minus the mean square. So it would be x minus x square. X bar square. Everything we have. So then we divide it by the number of data. Like we have we have a data set like this here. So if the mean, we calculate the mean from here. So we take 186 minus the mean and 186 minus the mean square, and then we take 20 minus the mean square, all of them minus their mean and square, then divided by, because they have 5 numbers, so divide by 5. So in this, the general form will be n. After that, we can find here the general form for the variance. This one, variance here. So when we want to find the standard deviation, we just take the square root of the variance, this one, minus x bar square over n. Here, that's formula in here. So we can find the variance and the standard deviation. Remember that the standard deviation is denoted like this way. Here, a circle, and then with a smaller line here. And the variance, because the variance is the square root of the standard deviation, it is the square root of standard deviation. So the variance is denoted like this one, square. So it's how we can find and understand standard deviation and variance. So it measures the spread of the whole data set. if the standard deviation is small, mean that all the data is quite near the mean, something like that. Quite near the mean, but if the standard deviation is big, so it means that the data quite separate from the mean, very long distance. Yeah. It would because the long distance, it will result that this one will increase, then will increase, so it will result in a big in the big and the large, or your values larger value for variance and standard deviation. So from standard deviation and from variance, we can understand more about the data. So now we will look at an alternative form of standard deviation. So we could here the form of standard deviation. If we have to take x values and minus the mean and then square of them, it's really complicated and wastes time to do so. Really hard to take x values and do this. So we have an alternative form which is easier for to use. So this is an alternative form for that. Okay, here let's look at the data set. 1 3 6 1 3 1. We have 6 data here. So for the first part, we will make a table, x and its frequency and x square frequency here. So for x is equal to 1, 3, and 6. We only have 3 values in here. Frequency 3, frequency 2, frequency is 1. 1 square will be 1 times my frequency 3 will be 3. 3 times 3 square will be 9. 9 multiplied by 2 will be 18. 6 square is 36 multiplied by 1 will be 36. So that sum, the total of these is 57 here. So for the mean of the data set equal to 415 over 6, which is equal to 2.5. So when we apply this one, so the square root of 57 over 6 minus by 2.5 square results in 1.80, 3 significant figure. So now we will move in a question so we can understand more about mean and standard deviation. So here, as part of her job in quality controller, Stella collected data relating to the life expectancy of a sample of 60 light bulbs produced by her company. The mean life was 650 hours and the standard deviation was 8 hours. The second sample of 80 bulbs was taken by the soap and resulted in a mean life of 660 hours and standard deviation is 7 hours. So we would find an overall mean and standard deviation. So first of all, we'll find our overall mean. Let's x bar equal to. So we have 2 samples. One sample contains of 60 buff and one sample contains of 80 buff. So we will find the total life expectancy of the 2 samples. 60 multiplied by 650 plus 80 multiplied by 660 over 60 plus 80, because it's the overall, so our total sample has 140 volt. So 9 to 1800 over 140 results in 656 hours. This one is round up to 3 significant figure. So next we'll find the standard deviation. From here, we do not have the raw data of above, so we cannot use the formula. This one we cannot use this one. It's really hard. So we will use an alternative form of the standard deviation. So here, first of all, because we have the mean life was 650 hours and the standard deviation was 8 hours. So here we know that for the first sample, 8 square, because the standard deviation was equal to x1 square of the first sample over n, which is 60 minus to 650 square. And then we have for the second sample of 80 volt, 7 square equal to x2. Here I denote them at the value of second sample square over 80 minus 660 square. So from here we can calculate x1 equal to 25,353,840 square. So for x2 square is 34,851,920. So from here we take the overall square. Overall square would be this one plus this one. We would have 60,205,760. So for the mean, the overall standard deviation is this number, 60,205,760 over sample 140 buff minus 655.71 square. So why here is not 656? Because in order to make our answer as accurate as possible, we will take the raw data from here. In here we round up to 656, but the actual number that we calculate was 655.71. So for the question, I advise you to take the 2 decimal place, the first 2 decimal place, in order to calculate it as accurate as possible. So for our final value, we have in here equal to 8.94 significant, round up to 3 significant figure. So it's how we can solve it for a question like this.